Let's start with what a variable is. A variable is a name container used to store information that can be referenced or updated later. Now, a variable can hold current price of a stock or the high price of a stock 5 bars ago. A program can have many variables that hold different values for different things. Now, the data type refers to the type of data that the variable can hold, which also determines the operations that can be performed on that data. Variables can hold numeric data like price or number of shares or contracts. Some can hold true or false values, which may indicate whether it's time to take a trade. The last type I'll talk about can hold text data like a name, phone number, or file path. Feel free to code along if you like. So I'm going to go ahead and just grab some code here real quick. So one thing about the TradeStation development environment is it has context-sensitive help. So if I click on this and I press F1, it's going to take me over here to this word, and it's going to tell me what once is. Same way, if I click on clear print log and press F1, it will tell me what clear print log does. So keep that in mind because it's very helpful when you're trying to figure things out and you're new. This up here is a comment block in green, so that's code that does not get executed. So let's bring in a couple of examples. So here I'm using a pre-declared variable. Let's look at these. Pre-declared variables are reserved words that have value 1 through value 99. And condition 1 is 1 through 99. Now the values hold numeric values and conditions hold Boolean values like true and false. So right now we're just going to look at 1. So this is a pre-declared variable and we're going to set its value to 10 and then we're going to print it. When I print it, it's going to go down to the print log down here. So let's see what happens. Now if I change that to 20, it's going to change it to 20. So I'm going to go ahead and set it back to 10. And then we're going to bring in a couple of more things. Now, here I used value 22 to show you that you don't have to use value 1, then value 2, then value 3. You can pick any of those values in between 1 and 99. So we're going to set this one to 55 and then print it. We're going to add these two together and set the result to value 99 and print that. So what do you think the values are going to look like down here? Let's see. 10, 55, and 65. That's exactly what I expected. One last thing we want to look at before we go on to user-defined variables is this condition. So right now I have it set to false, and we're going to print that. Now we got false. I can go in and change this to true and recompile it, and it shows true. So I'm going to go out to variables. Now we're going to go on to user-declared variables. So let's go look at how to define a variable. So when you define a variable, you can use the word variable or var, vars, variable. They all work. It just depends on what you like. Followed by the name of the variable and the default value that you want to assign to it. So let's look at a couple of examples of that. Let's get rid of this. And we're going to go up to the top before the once statement, and we're going to go ahead and define these. Now, these are implied variable declarations, meaning that they don't have a data type in front of them. So if we go back and look at the syntax for this, we're going to see that it's variable, which I use var in this place. We can define interbar persist, so anything that's in this little bracket is optional, but the variable name is mandatory, and it needs to have an initial value. And you can add a data number here. This is just showing the next iteration of it, saying that the next iteration is optional, but you can use a comma. Again, you can assign interbar persist, the data type, the variable name is mandatory along with its initial value. So now we want to see what the variables look like. So when we do this with the print statement, it's going to show up down here in the print log. If you can't see the print log, go up here to View and select EasyLanguage Print Log, and it should show up. And if it keeps disappearing, you can open it and then pin it there. So let's run this. And here we get false, a string value, and 55. Now, one thing about implied variable declarations is you don't know what the compiler is going to do when it assigns the data type to the variable. So I could change this to 21. 21 is not a Boolean value, but it's being assigned to a Boolean value variable. So it doesn't make sense. But the compiler let me do it because it's not typed. But if I come in here and type bool in front of it, now it complains. It says it can't implicitly convert numerical to true false. So here I explicitly did a variable declaration. So we'll get to that next. So I'm going to go ahead and send this back to false. But I just wanted to show you that it looks like you can just change the data type. But once the compiler determines that the data type is whatever it is based on what you have typed here, then it will keep that type. We can actually print the data types with this. So now we have a Boolean value. We can use the method getType, but it returns something we can't print, so we have to turn it into a string. And the same way with the string value. So let's see what we get. So based on this being false, it set the data type to bool val as a EL Boolean. The string data type was assigned to the string val. Now, I want to show you this. Let's uncomment this. Now we get an error. Well, the problem is that we have multiple numeric data types. We have byte, integer, which is 32-bit. We have a 64-bit integer. We have 32-bit and 64-bit float values, which are floating point numbers. So it doesn't know what type to convert 55 to because we didn't give it a data type. So it can't actually get the type of it. Now we're going to look at explicitly typed variables. We're going to get rid of this. Verify that. Now notice we use the var. So it's a reserved word and we can use variable, vars, variables. I like the short version because I type a lot of code and the less code I have to type, the better. So here we're going to look at these value types. So if I click on one of these, it should take me to the value type. So here we see the value types and all of these value types are here. Now what we want to do is we want to look at what these look like in the print log. So we're going to put these here and look at them. Sure we got them all. So this is false. 128, 8812, minus 1234, minus 10.7, 20.8, and welcome to EasyLanguage. That's pretty much what we expected. These are explicit variable declarations because they have data types in front of them. Now, remember early on when I declared that Boolean val and I turned it to 55? Now look what happens. Now it says cannot implicitly convert numerical to true false. It knows that I'm trying to convert 55 to a Boolean value and it says, nope, you can't do that. So let's print some of these. I'm only going to do a few of these. Let's get the types of these guys. So here we see EL Boolean and EL double, which is what I would expect. Now, one nice thing about these is these variables are actually objects, and I'll show you how they are. We're going to look at the max value and the min value that you can have for each one of these data types. We go to the inheritance hierarchy. You can see as it goes up the tree, it actually comes back to object. So these variables are actually inheriting from object. But I'll talk about object-oriented programming at a later date. So we're looking at max value and min value. Now we're going to look at the min-max values for each of the data types. So we do that by calling a method on the variable, the min value and the max value. And we're going to do that for each one. So let's verify that and see what happens over here. The minimum value for a byte is 0 and the maximum value is 255. And then this just goes through all the minimum and maximum values. So if we come all the way down here to double, you can see that that's quite a rather large number. Now I want to address this implicit conversion may lose bits of precision. We see it here and we see it here. We get this warning after we do the compile. And what I believe is the compiler is taking this minus 10.7 value and it's upcasting it to a double. And then it's trying to put a double inside of a float value. The problem with that is 64 bits doesn't fit into 32 bits without the potential loss of precision. The same thing is happening with the byte. We notice the error comes up on that one. It's probably upcasting this 128 value to a 32-bit integer, and then it's trying to put that into a byte. So it's saying, hey, there may be loss of bits of precision. It really depends on what the value is. 8812 would not fit into a byte, so there would be loss of precision. If the value was 24, then it would fit in there. It's just something we have to be aware of, but it's not something that we can change. I do want to show one place where you need to pay attention to this warning, and that is if you have code down here that actually tries to assign some type of double variable into an int. So if we recompile this, we'll get a third implicit conversion warning, and it'll be on that. So the other ones we can't do anything about, so pay attention to these when they're in your code when you get them. Make sure that value is not going to be any bigger than that one. If it is, you may lose bits of precision. Also, these types of bugs are very hard to track down. All right, the next thing I want to show you is constants. I like to put my constants there. I like to name my constants all caps with an underscore if I need to. A constant is something that you can't change. You assign it once and it stays that value forever. In fact, if you try to assign it, then it will give you an error. So let's look at constant. You can use constant, constant, and constants. Again, I like to keep things short, so I go for these. So let's try to assign something to max entries 20. This word cannot start a statement. So there you go. We can't assign something to a constant. But we can print the constant. We can print the value of it. And here we see 50. If we change that to 40, it changes. All right. One last thing we want to look at is inputs. Inputs determine values that let the user define how they want the indicator or study to run, or a strategy. I like to put the inputs up here above the constants. So I like using inputs, constants, variables, my once block, and then my main code loop would go down here. Let's print out some inputs. All right, so we have 6, close, var, and types. Well, I don't know what it was when it printed it, but it was evidently 55, 59. Now, one thing I want to show you is if I change this to a 5, this to high, and recompile it, I'm going to turn off our clear print log. Look, it didn't change. The reason it didn't change is because these are default values. So if you put an indicator on a chart, it's going to get the default values. Then if you modify them on the chart and then recompile this, you don't want the chart to change its values back to the default values. You want it to keep them. So that's the reason it doesn't change. If I want the new values on the chart to be 5 and high for price, then I have to actually go to the chart and change the study. Okay, that'll do it. Let's head over to the tips. The most commonly used data types are int, double, and string. Choose the correct data type for the task. If you're storing price data, a double is a better choice than an integer because it may lose bits of precision. So if you're storing like 100.62 into an integer, it's going to drop to 62 and it may even round up to 101. Favor user-declared variables over pre-declared variables. If your code is full of these pre-declared variables like value 1, 2, and 3, you're going to be looking above for where you assigned a value to these, and then you're going to be looking below to see where you actually use this. And it's a lot of up and down through the code. It gets very tiresome. Here we're doing a position sizing calculation for a trade where we take the capital divided by the price and come up with the number of shares. Good variable names make code easier to read and understand. Favor explicitly typed variables over implicitly typed variables. The implicit type variables do not have a data type in front of them. The explicitly typed variables do have a data type in front of them. Now, explicitly typed variables can raise compile time warnings that can point you to a potential problem, such as implicit conversion does not lose bits of precision. Implicitly typed variables won't raise this warning. Explicit declaration is a good programming practice and it shows intent. It means the developer meant to do this. Where implicit is implied or left up to interpretation. So sometimes when you look at somebody else's code or you come back to your code in 6 months, you're like, well, what was my intention here? And it can lead to subtle little nuances within the program. Constants should be used for values you don't want to change. Max trades per day, 3. Max loss per day, 300. It's also a good defensive programming practice because it keeps the program from accidentally changing the value. And declaring data types on variables is consistent with functions and methods. When I talk about those later, you'll see how you have to define those on functions and methods. Well, that's all for now. Don't forget to like and subscribe. If you have any questions, leave them in the comment section below. Thanks for watching, and I hope to see you in the next video.